In this video, we're going to practice identifying whether something is or is not an exponential function. So I have several examples here. We're going to look at them and see if they meet the definition of exponential function. Recall that an exponential function is a function of this form, a times b to the x, where a is any non-zero number and b is any positive number not equal to 1. Now, why are there these conditions on a and b? Why does a have to be non-zero? Well, if a were 0, then we're multiplying by a, so the whole thing would be 0. So that would just be the 0 function, right? And we've already said the 0 function is an example of a polynomial, for instance. So we don't want that to be an exponential function. Why can't b be equal to 1? Well, if b was equal to 1, you know that 1 to any power is also equal to 1. And if we multiply 1 by a, we just get a. So now we just have a constant. And we don't want a constant to be called an exponential function. So that's why b can't be 1. And we don't want b to be negative or 0 because it creates some weird things. Okay, so let's take a look at these and see if they meet the definition of exponential function. Let's take a look at this first one here. 4 to the x. Well, we just have to see if we can find numbers a and b so that this fits the definition. And sure enough, if I take a to be 1 and b to be 4, this is exactly matching the definition. So this is an exponential function. What about this one? Well, if we look carefully at this, I think I see a problem. If we look at the definition of exponential function, the x has to be in the exponent. Right? I can't find numbers a and b so that this is a times b to the x. So this does not work. This is actually a polynomial. Polynomials are not exponential functions. What about this guy over here? Well, let's see. Can I find numbers a and b so that this matches the definition? Well, I could have a be 1 and b be negative 5, but look at the requirement on b. b has to be a positive number. Here this number is negative. So that does not meet the definition. What about this guy over here, square root of x? Well, I know I can write this as x to the 1/2, but now I see I have the same problem as I had over here, right? The x needs to be in the exponent for this to be an exponential function, and that is not the case here. What about this guy over here? Well, at first glance, you might say, well, no, that doesn't look anything like that form that is required in the definition. But if we can put it in that form, it is an exponential function. So let's think about this. Can we put this in that form? Well, if we think about properties of exponents, we know that this is the same thing as 1/2 to the power x. And now we are in the form. A is 1, b is 1/2, and so this is meeting the requirements of an exponential function. This is an exponential function. Finally, let's look at this last one. Well, this one looks pretty messy up here, right? It's not just an x. We're supposed to just have an x to match the definition, but maybe we could do a little bit of algebraic manipulation like we did up here to fix it up. So let's see. How could I write this? Well, I know I can write this as 2 to the 4 times 2 to the 3x. I know that when I multiply these, I add the exponents. That's what's happening over here. So I can pull it apart this way. 2 to the 4 is the same as 16. And what about 2 to the 3x? Well, this is the same thing as 2 cubed raised to the power x. And what's 2 cubed? 2 cubed is 8. So this is 16 times 8 to the power x. And we see that a is 16, b is 8, and so this matches the definition of an exponential function. So yes,